Hey, so we are doing homework number 7, problem number 5, where the probability that x equals 0 also equals the probability that x equals to 1, which equals to 1/2, and y is a continuous random variable uniform from 0 to 1. So the first step that we need to do is draw out the graphs. So the first graph, f of x equals to, or looks like this, where there's two impulses at 0 and 1 of 0.5. Okay, and now we want to look at the y graph, okay, which looks like uniform from 0 to 1, and this thing equals to the area 1. Okay, and so basically you want to convolve this with this, okay, because you know the other things that we are given is that x and y are independent and z equals to x plus y. If this is true, then this should also be true, equals to f of x z convolved with f of y z. Okay, so basically how we find f of z is by convolving f of xz with f of yz. How do we do that? We do that by pretty much writing out the formulas for each of these two graphs. So for this first one, this equals to 0.5. You have a delta value at z plus 0.5 with a delta value at z minus 1. Okay, that's our first graph. And our second one right here is just u of z minus u of z minus 1. Okay, so we convolve these two equations, and I'm going to do that right now. So f of z equals to f of xz convolved with f of yz. So that equals to 0.5 delta z plus 0.5 delta z minus 1 times the quantity of u of z minus u of z minus 1. So basically after convolution, you basically FOIL this out. I figured out that it equals to 0.5 u of z minus u of z minus 2. So basically if we graph this, well, this is f of z first of all, and now we have to graph this, okay? Okay. We have our 1 and our 0.5. So it is still 0.5 at u of z, and then u of z minus 2, you move it over to the right once, and then you get, sorry, that's the equation we're graphing right here. So, but it's still at 0.5, so you keep going at 2, and this is the graph of f of z, where f of z equals to 0.5 u of z minus u of z minus 2. And that completes the problem.